Hello again, welcome to lesson 4 in our radicals unit. Our video again is going to be in two parts today. In part 1 we're going to discuss simple operations with radicals including addition and subtraction, and in the second part we're going to move into multiplying simple radicals together. So first we're going to discuss addition and subtraction, and just like any addition and subtraction problem, I have to have like terms to be able to add or subtract radicals. So we need to go back and think, well, what was a like term? Here, 4 and 5 are like terms because they're just arithmetic numbers. They don't have a variable attached to them, so I can just add or subtract them easily. When I move into numbers with variables, the important thing to remember is that the variable has to have the same power. Okay, the variable needs to be the same, and it has to be to the same power. 3x and 4x are like terms because they have the same variable x, and x is raised to the first power on both of these. 2x and 5 are not like terms. Well, first, 2x has a variable and 5 does not. If 5 had a variable, it would be raised to a 0 power, which we don't want to deal with right now. So, 2x and 5 are not like terms. Remember, you can only add and subtract like terms. For cases like 2x and 5 where you don't have like terms, if I was to add those together, the best I can do is write 2x plus 5 and go about my merry business. I can't combine these numbers in any way. This is as simple as it gets. I join them with an operation sign, either addition or subtraction. Whereas 4 and 5, I can go ahead and add those together to be 9. Okay, so let's look at 3x and 4x. Let's go back and think way back when we first started dealing with algebra. What did 3x plus 4x mean? And really that meant that I took 3x's, okay, 3x's, and 4x's, and we want to know how many x's do I have all together. So I would count 1, 2, 3, 4, 5, 6, 7. So I end up with 7 x's. Eventually, through our years, we learned that the shortcut to that is I take the coefficient, which is the number in front of the variable, not the variable, but the number in front of it, and I can perform whatever operation it asks me on the coefficient. So here I would take 3 and 4 and add them together to get 7. Then I don't do anything to the variable. As long as it's a like term, I just bring over the variable. So 3x plus 4x, I'm going to have 7 x's all together. Okay? All I'm changing is the coefficient. It's the same thing when we subtract. Look to see our like terms. We both have a variable of x, and it's raised to the same power. It's raised to the second power. So I don't change the variable. I still have x squared. All I'm doing is taking the coefficients and performing the operation. So 10 minus 6 gives me 4. So 10x squared take away 6x squared is 4x squared. Okay? So we're doing the same thing with radicals. But for radicals to be like terms, instead of having a variable, we have a radicand. I look at two things. If the index and the radicand are the same, then radicals are considered like terms. So here, if my index and my radicand, the number underneath the radical symbol, are the same, then the two radicals are said to be like terms. And then I can add or subtract what we call the coefficient of the radical, whatever number is being multiplied out here. Let's see what that looks like. Here I've got 3 times the square root of 2 plus 5 times the square root of 2. So this is kind of like our mental checklist for dealing with operations with radicals and whether or not we can add or subtract or multiply them. Are the indexes the same? For a square root, remember the index here is an understood 2. So 2 and 2, yes, my indexes are the same. I need to look to see if I can simplify the radicand. Okay, can I simplify 2 any farther? And the answer is no, I can't. So this is as simple as it gets. So we're good for step 2. Now step 3. Are the radicands the same? Here, I've got 2 and 2. Yes, they are. They are the same. So I can answer yes to 1 and 3. The indexes are the same. The radicands are the same. So then I get to perform whatever operation, in this case it's addition, to the outside numbers. Okay? So I'm going to take 3 square roots of 2, and I'm adding 5 square roots of 2 together. How many square roots of 2 do I have? 3 plus 5. Okay? So I end up with 8 square roots of 2. You see how this process is the same as if this was 3x plus 5x. I would keep x the same, and 5 plus 3 is 8. I end up with 8 x's. Here, my x just becomes a square root of 2. 3 square roots of 2 plus 5 square roots of 2 gives me 8 square roots of 2. Okay, let's try another one. Here I have 12 square roots of 5 plus 3 square roots of 7 plus 6 square roots of 7 minus 8 square roots of 5. So the first thing I need to look at are the indexes. Here, this is a square root, so my index is 2. Index is 2, 2, and 2, so that's good. Now I need to look to see if I can simplify any of these radicals. I can't simplify 5, it's prime, 7 is prime, 7 is prime, 5 is prime, so I can't simplify any of these any farther. So then I move to see which ones have the same radicand. And I see here that I've got a radicand of 5 here, so I've got 12 square roots of 5. See if we can find any like terms. 3 square roots of 7 is not a like term because even though the indexes are the same, the radicand here is 7, the radicand here is 5. So this one is not a like term, but this is a like term. I always want to remember to include the sign directly in front of the coefficient. So that minus sign goes with my 8. So I have 12 square roots of 5 minus 8 square roots of 5. So when I combine these, 12 square roots of 5 minus 8 square roots of 5, how many square roots of 5 do I have? And I have 12 minus 8, which is 4 square roots of 5. So then I need to go ahead and look at my other radical. I have a radicand of 7, so this is a like term. It's got a radicand of 7. Okay? So I have a positive 3 square roots of 7 plus 6 square roots of 7. How many square roots of 7 do I have? I have a positive 9 square roots of 7. Okay, you see how that works? It's just like if we were dealing with variables. 4 square roots of 5 plus 9 square roots of 7 is the simplified form of this string of radicals. So let's make it a little more difficult. Let's do unlike radicands. Okay, so what do I do here? Well, first I need to check the indexes. Here, my index is 2, 2, 2. We're good there. So now we need to see, can I simplify any of these radicals? You can either simplify using prime factorization or by using the perfect square method, since all of these are square roots. I'm going to use the perfect square method because I think it's a little quicker. So the square root of 20, I know that the square root of 4 times the square root of 5 will give me the square root of 20. 4 is a perfect square. This becomes 2. Remember my outside numbers here, I multiply together. So 2 times 2 is 4, and I'm left with square root of 5. Okay? 45, I know, is the square root of 9 times the square root of 5, because 9 times 5 is 45. Square root of 9 simplifies into 3, so I'm going to multiply my outside numbers. 3 times 3 is 9, and I'm left with square roots of 5. Okay, notice this is a positive, so let's bring down our plus sign. 180, I know, is the square root of 36 and the square root of 5. Can simplify the square root of 36 into 6. Okay, So I'm multiplying it by the understood 1 out here, so 6 times 1 is 6, and I'm left with the square root of 5. And again, it's a positive. So now, notice that I have turned each one of these radicals into radicals which are like terms. They each have an index of 2 and a radicand of 5. So then I can just add my outside numbers. 6 plus 4 is 10, plus 9 is 19, and I keep my radicand the same. Okay, so altogether I have 19 square roots of 5. Let's try one more where we need to simplify the radicands in order to end up with like terms. Here I've got 6 in the square root of 27. So let's simplify 27, and I know 27 is 9 times 3. So the square root of 9 times the square root of 3 gives me 27. 9 will simplify. The square root of 9 simplifies into 3. So I multiply these numbers. 3 times 6 is 18, and I'm left with the square root of 3. 12 will simplify into the square root of 4 times the square root of 3. Square root of 4 simplifies into 2. So I multiply 8 times 2, which is 16 square roots of 3. And again, it's a positive, so I'm going to add a plus sign. 75 is 25, square root of 25 times the square root of 3. Square root of 25 simplifies into 5. Multiply, 5 times 2 is 10, square roots of 3, an addition sign again. So now I've turned these 3 radicals into 3 radicals of like terms. They each have an index of 2, radicand of 3. So I can add my outside numbers. I can add 18 plus 16 plus 10. So 8 plus 6 is 14. 1, 2, 3, 4. Okay, so my outside numbers add to give me 44, and I'm left with 44 square roots of 3. So that concludes our first part of this video. Continue watching part 2 to learn about multiplying radicals.